in the mission of this biodiesel, biofuel mission, this JATROPHA had got good momentum. Most of these farmers, they cultivate the JATROPHA in their cultivable land. Actually, this JATROPHA, we cannot cultivate this JATROPHA on the fertile land. But some of the farmers, they used to cultivate this JATROPHA on their fertile land. And actually this seed, the JATROPHA, in the fruit of this JATROPHA, it contains the three seed, and its weight is very less. In 1 kg of this JATROPHA, it accommodates actually 1350 number of these JATROPHA seeds. So it is very lightweight. It is very lightweight. So therefore, the farmers, they could not get the face the prices after the sale. So therefore, the program of this cultivation of this JATROPHA on the fertile land, it fails. Now we will discuss one by one. So this is the introductory part. What is the petroleum scenario? We know that India is not self-sufficient in petroleum, and we import 2/3 of our requirement from the other country. And the import of petroleum product, we import rupees 1.60 crore per annum for the import of this petroleum product. So import bill has serious consequence on the economy, and biofuel have positive effect on reducing imports. Actually, this figure 1.60 crore per annum, I think this figure is wrong. I have to check that figure. In the transport sector, there is a excessive smoke emission from the vehicle. It contains mainly carbon monoxide, sulfur dioxide, NOx, SOx. And because of this pollution, we know that there is a greenhouse effect, climate change. Most of these, our earlier speaker, they discuss about the climate change. Then what is the alternative? In the transport sector, mainly the liquid fuel, that is petroleum product, it is being used. So the alternative is we can use solid fuel, we can use gaseous fuel, or we can use liquid fuel. But there is a restriction. We cannot directly use solid fuel in the transport sector. There is also some limitation to use this gaseous fuel in the transport sector, but mostly the liquid fuels are used in the transport sector. So this is one of the statement of this Rudolf Diesel in 1912. The use of vegetable oil for engine fuels may seem insignificant today, but such oils may become in the course of times as important as petroleum and coal tar products of the present time. Actually, the first engine which was invented is meant for the vegetable oil. Peanut oil was used during that time, but after the advancement of these fossil fuels, different fossil fuels are derived, the different processes are evolved, then that engine is switch over to use the fossil fuels, that is petroleum product. But the first engine which was invented, it is for the vegetable oil. So Rudolf, this is the statement of this Rudolf Diesel. Then what are the importance and advantage of biodiesel? So this biodiesel, if we use the non-edible vegetable oil for the preparation of this biodiesel, then it contains oxygen. So it is completely natural, renewable, and it is the 100% vegetable oil based fuel used for all conventional diesel engine. In all types of diesel engine, we can use this biodiesel. 20% of this biodiesel can be used, which means we can blend 20% of this biodiesel with our conventional diesel. And it is the recommendation of our government of India. Then environmentally friendly fuel, it reduces the emission, visible smoke, particulate matter, and bad odor. Although it reduces the other emissions, means carbon monoxide, SO2, but there is a enhancement of NOx emission. Then very simple hydrocarbon chain containing negligible sulfur and other aromatics. And it is a biodegradable 4 times faster than fossil fuel. Swati, may I audible?
Yes, sir.
So it is an oxygenated fuel. We can call it as a green fuel or biofuel. Its flash point is more than 100 degrees centigrade. Therefore, it is very safe for the storage because it is non-inflammable. If we compare the properties with the diesel, the flash point of this biodiesel is more. The flash point of this diesel is very less, up to 50-55 degrees centigrade. Means at that temperature, it may ignite. But this biodiesel its flash point is more than 100 degrees centigrade. Again, this biodiesel can be blended with the petroleum diesel at any proportion. Means up to 100% we can mix in the petroleum diesel. Then it is easy to handle and easy to store. It can be produced domestically with simple technique and cost is comparable with the diesel. Then what are the different advantages of vegetable oil as a diesel fuel? So it is a liquid fuel. Therefore, its portability is more. It is readily available. It is renewable, high heat content, lower sulfur content, and it is biodegradable. We already discussed all these points. Then the problems in using neat vegetable oil. We already discussed this point. We can directly use this vegetable oil. Again, non-edible vegetable oil. If we consider the case of karanj, we can directly use the karanj oil without esterification, trans-esterification, means without preparing its biodiesel. We can directly use this karanj oil in the engine. If we provide the heat to this karanj oil, then its viscosity reduces. Then what are the different operational problems in the engine? If we directly use this vegetable oil, starting ability, then ignition will be incomplete. Then combustion parameters, incomplete combustion. Performance parameter, performance of the engine will be less. These problems are attributed because of this high viscosity. Because these vegetable oils, its viscosity is high. Then extremely low volatility. These are the operational problems. Then durability problems. There will be deposit formations, carbonization of injector tip, then piston ring sticking, lubricant oil dilution, then fuel filter plugging. These problems can be handled by using the process of trans-esterification. Means if we process this neat vegetable oil by the process of trans-esterification, then we will get the biodiesel. That process is called as trans-esterification. Means vegetable oils need to be trans-esterified for their conversion to biodiesel. So by using the process of this trans-esterification, we can convert this non-edible or any vegetable oil into biodiesel. Then what is meant by biodiesel? This biodiesel, it is also called as alkyl ester. It is a cleaner burning diesel. This fuel is made from natural renewable source such as vegetable oil. It is called biodiesel because it is made mostly from biodegradable material and can be used as a fuel in the diesel engine. Therefore, it is called as biodiesel. The use of this biodiesel in conventional diesel engine result in substantial reduction of unburned hydrocarbons, then carbon monoxide and particulate matter. And the emission of nitrogen oxides are either slightly increased depending on the duty cycle and testing method. So by using this biodiesel, Other means carbon monoxide, carbon dioxide, then unburned hydrocarbon, then sulfur dioxide. These emissions is reduced, but the emission of this nitrogen oxide increases because of the high temperature. The use of biodiesel decreases the solid carbon fraction of particulate matter since the oxygen in the biodiesel enable more complete combustion to CO2 and eliminates the sulfate fraction as there is no sulfur in the fuel because this is this fuel is obtained from this vegetable oil. Then what are the disadvantage of raw vegetable oil as a fuel, as a diesel fuel? We know that its viscosity is more. We already discussed. Then overload to injection pump, higher fuel consumption, poor atomization, then incomplete combustion, carbon deposit, and engine failure. So these are the disadvantages of raw vegetable if we use this raw vegetable oil in the engine. Then what are the methods how we can use this vegetable oil to reduce the viscosity? Means these are the different viscosity reduction methods. These are the different viscosity reduction methods. We can blend this non-edible oil with the diesel, means blending with diesel. If we provide the heat, second method is the heating. If we provide the heat, then again its viscosity is reduces. Then another method is thermal cracking, and then trans-esterification. So this trans-esterification, we will discuss this process, trans-esterification, later on, how this process is carried out. Then what are the different feedstocks available for biodiesel production? JATROPHA carcass oil. JATROPHA, it is also called as one errand or jungli errand. Pongamea pinnata. Pongamea pinnata means currants. Then we can use this mustard oil, rice bran oil, neem oil, rubber seed oil, salseed oil, palm oil, cottonseed oil, rapeseed oil, sunflower oil, soybean oil, castor oil. Then we can use vegetable oil, fish oil, or animal fats or tallows. So these are the different feedstock for biodiesel production, and these feedstocks are region specific. In Western Maharashtra, this Pongamea pinnata means currant is available. Also in some part of Karnataka, this is available, Pongamea pinnata. Then mustard oil, these are the edible oil, and it is not recommended to use the edible oil for biodiesel production. Then in Konkan region, undi seeds are available. We can also use undi for biodiesel production. If we go in our eastern Vidarbha, mahua seeds are available. We can use mahua for biodiesel production, or we can use neem seed oil for biodiesel production. So these are the region specific. So these are the different raw materials which are available in the various countries. Rapeseed, it is being used in Europe. Then sunflower oil in Italy, France, and Thailand. Soybean in Malaysia. Palm oil in Malaysia. JATROPHA, it is in African countries, Nicaragua, South America, and in some parts of India, like in Chhattisgarh. Linseed and olive oil in Spain. Cottonseed oil in Greece. Tallow and used frying oil. Actually, in our India, Gujarat, there are some biodiesel production plant, and they mostly use the oil, means the waste oil after the frying. So this oil is collected from all the hotels, and which is then trans-esterified and prepare its biodiesel. So it is available in the market. Then JATROPHA carcass. So the material of choice. These are the different materials which are available for biodiesel production in the different countries. So these are the photographs of Pongamea pinnata, mustard, castor bean, then JATROPHA. Animal fats. Algae can also be used for biodiesel production. So we will discuss JATROPHA first. So there are 70 species which are available in the world and 9 species are available in the India. So this is the oil yielding plant, a multi-purpose and drought-resistant large shrub. Its height is 5 meters and yield 2 to 5 tons per hectare per year. And oil is up to 30% by weight basis. Oil seed yield per hectare per tree 1 to 4 kg, and oil content of the whole seed 30 to 40%. And we can prepare the biodiesel from the JATROPHA oil by the process of transesterification. So these are the JATROPHA kernels, and in each kernel it contains the 3 seeds. Its color is black, JATROPHA seeds. Actually, when I had been at Parbhani, I collect these JATROPHA kernels from Latur area, Umarga, and we process this seed. We collect this seed, then decorticate this seed, and we collect the oil after pressing this oil in the oil mill. We can use this JATROPHA in the fence. So these are the JATROPHA seeds. Then this is the JATROPHA nursery. One of the project in the oil mission, this non-edible oil mission by NOVAD board from Delhi, they have given one project to the TNAU, Tamil Nadu Agricultural University, to develop these hybrid varieties of JATROPHA, because the yield of this JATROPHA is very less. So they have given one project to develop some hybrid varieties of JATROPHA. But today I don't know whether they have developed these varieties or not. But during my visit at TNU, at that time I have received this information, because in the NOVAD project, they have received some large amount to develop this species. So this green is the unripe fruit of this JATROPHA, and this is the ripe fruit of this JATROPHA. And this plant is like a shrub, and it contains the seed. So this is the complete picture of the JATROPHA carcass. This is at the ripening stage of harvest. So these are the seeds. After decortication, we get the seed. And this is the oil. So first, the oil expeller. We have to filter this seed through the filter press. Then it also requires a steam boiler, storage tank, pump, and other accessories. Before crushing of this JATROPHA seed, it requires some heat treatment. Only by giving the heat treatment, the oil glands which are present in that seed, that glands means the oil will remove in the steam treatment. If we directly crush that seed in the oil press, the oil recovery will be very less. Only we get the 10 to 15% of the oil. But if we provide the steam during the extraction of the oil, then the oil recovery will be 25 to 30%. So in the oil extraction process, it requires, so this is the oil, this is the screw expeller, and this is the elevator. The material is elevated and it is the feeder. In the screw expeller, we get the oil. So this boiler arrangement is also there to provide the steam during this expeller of the expelling of the oil. The oil which is removed from this which is received from the screw expeller, which is stored in the tank. Then this is the filter unit, and after that we have to store this oil in the oil storage tank. So this is the complete process of the oil extraction. So this is the photograph at MAU Parbhani. At that time, they have planted this JATROPHA carcass on 300 hectares. For that purpose, for the plantation of this JATROPHA, at that time they have received lakhs of rupees, but after 2 to 3 years, they had uprooted all these JATROPHA plants because the yield was very less. Also, it requires some irrigation also, and because of the yield problem, all this JATROPHA plantation, JATROPHA, these plants, they were uprooted. So these are the JATROPHA fruits that we had been collected from Umarga, Latur, and after sun drying, we use this groundnut decorticator for the removal of this upper layer, upper husk of the seed, and after a decortication, so this is the process of decortication, because this operation is more labor intensive. If we use manual labor to remove the seed from the JATROPHA carcass, it requires more labor. That's why we use this grounded decorticator for this purpose, and it reduces the labor. Again, we collect this currant seed from the campus. In that campus, the currant trees are available, and we collect these currant seeds. Then this is the operation of this oil extraction. We feed this JATROPHA seed in the oil expeller. This is my BTech student. At that time, he had given one experiment on this biodiesel, domestic biodiesel production from JATROPHA and currants. So here, this is the this wall is steam regulating wall, and during the oil extraction process, it requires the steam, that is heat treatment. So this is the collection of this oil. Oil is collected collected, and this is the oil expeller. Here we have to filter that oil, all the unwanted material we have to remove before transesterification, before taking that oil for the transesterification. And this is the boiler. From here, from this boiler, the steam is prepared, and that steam is supplied to that oil extraction unit. So this is the steam generating unit. And here he regulates that supply of the steam. And we collect this JATROPHA oil. And in our laboratory, we prepare on a small scale this domestic biodiesel processor. Actually, in the biodiesel production process, during the process of this transesterification, it requires the heat as well as stirring. We have to heat the oil. We have to maintain the temperature of the oil up to 60 to 65 degrees centigrade, and we have to stir that mixture of the oil. In the oil, again, we have to mix methoxide, sodium methoxide or potassium methoxide. And we have to keep that mixture for 1 to 1.5 hours, and we have to maintain the temperature of 60 to 65 degrees centigrade during the process of the transesterification. So this is the stirrer, and here this is the temperature indicator, and some sensors are there. So this is the small scale biodiesel processor. So we extract the JATROPHA oil, and we use the JATROPHA oil for biodiesel production. So this is the JATROPHA biodiesel, which is prepared by using this JATROPHA oil. So this is the biodiesel, JATROPHA biodiesel. We actually prepared this biodiesel in the laboratory. During this process of the transesterification, what happens? In the process of transesterification, we get raw biodiesel and glycerin. Means whatever amount of this glycerin which is present in the oil, which is separated during the process of this settling. This is the settling process, and we use this flask to remove this glycerin. So at the bottom, you have seen this is the glycerin. Because the density of this glycerin is more, that's why it settles at the bottom. And this biodiesel its density is less, therefore it floats. So it is called a separating funnel. We use this separating funnel for the separation of this biodiesel and glycerol. And this is the JATROPHA cake after the extraction, oil extraction. We can use it as a fertilizer. So in the biodiesel production process, generally we use the trans-esterification process. It may be acid catalyst-based reaction, alkaline catalyst-based reaction, catalyst-free based reaction. Actually, in all these vegetable oil, it is a trans fatty acids. All these vegetable oils are the trans fatty vegetable oils. And before going to start this trans-esterification process, we have to check the free fatty acid content in that oil. If the free fatty acid content is less than 1, then we have to directly go for this alkaline catalyst-based reaction. If the free acid content is more than 1, then we have to use this acid catalyst-based reaction. So the content of this free fatty acid means what amount of this free fatty acid contained in that vegetable oil has a more importance. First we have to decide how much is the free fatty acid contained in that oil. Then this alkaline catalyst based reaction, this reaction is governed at a low temperature. It requires the low temperature and pressure. Its conversion efficiency is high and reaction time it will be less. It requires 1 to 1.5 hours. So this is the reaction. So this is the vegetable oil. In the vegetable oil, we mix sodium methoxide or potassium methoxide. What is my sodium methoxide? Sodium hydroxide. We use methyl alcohol, and we mix sodium hydroxide pellets in the methyl alcohol. Or we use potassium hydroxide pellets, and we mix the potassium hydroxide pellets in the methyl alcohol. And here, this sodium hydroxide, it acts as a catalyst. So this vegetable oil, if we take 1 liter or 1 kg of vegetable oil, we require 200 gram of this sodium methoxide. Then after the process of this trans-esterification, during this process, we have to maintain the temperature of 60 to 65 degrees centigrade and the stirring of 700 to 750 RPM. We get the methyl ester and glycerin. This methyl ester, it is the raw biodiesel, and this glycerin, we have to separate this glycerin. You have seen here. So this is the methyl ester, raw biodiesel, and this is the glycerin. After settling, after this process, we have to keep this mixture for settling. And after the settling, here this raw biodiesel will float on the upper side, and this glycerin will settle at the bottom. And this is the chemical reaction. And this NaOH or KOH, it acts as a catalyst. So this glyceride mixed with alcohol, we get the ester and glycerol. This vegetable oil reacts with alcohol in the presence of catalyst, and after reaction, the end product, we get the biodiesel and glycerol. Actually, this methyl ester, it is the raw biodiesel. It also contains some traces of this sodium methoxide. Means we cannot directly use this raw biodiesel in the engine. We have to wash this biodiesel. Means first we have to remove the traces of this sodium methoxide which is present in the raw biodiesel. So for that purpose, we have to wash that biodiesel. Then what is the effect of acid value and water? If the acid value of the glyceride is less than 1, it should be less than 1. All material should be anhydrous, means there should not be any water contained in the oil. If the oil contains some traces of water, then there will be a process of saponification and the soap will be formed. Means the end product will not be biodiesel, the end product will be soap. Otherwise, catalyst requirement will be more to neutralize, and soak causes more viscosity and gel formation, and the separation will be very difficult. Means the oil which is used for biodiesel production, its acid value should be less than 1 and it should be anhydrous. It should be anhydrous. So in the biodiesel production unit, it contains oil storage tank. It will
Sir, you are not audible.
So we discuss this reaction. So in the biodiesel production unit, it requires oil storage tank, then biodiesel reactor, catalyst preparation tank, biodiesel storage tank, glycerol settling tank, then crude glycerol storage tank, washing tank for crude biodiesel, steam boiler with control, and pipe and accessories. So in the biodiesel processing unit, all these machineries are required. So this is the process. This is the process. First we collect the seed, then we extract the oil from these seeds. Then it requires some preheating. If this oil contains some water, because of this preheating, only means we have to make this oil uh, without we have to preheat this oil. Then we have to remove all traces of this water from this oil. Then we have to mix sodium methoxide. This sodium methoxide is a mixture of methyl alcohol plus sodium hydroxide. So this methyl alcohol, it requires for 1 kg of this oil, it requires 200 to 250 ml or 250 ml of this methyl alcohol, and here we add 1 to 5 gram of this sodium hydroxide. Then we mix this sodium methoxide in the oil. Then we stir this mixture for 1 hour and we provide the heat at 65 degrees centigrade temperature. We maintain this temperature for 1 hour and During that process of trans-esterification, we get this biodiesel and this glycerin. This biodiesel is raw biodiesel. It's raw biodiesel. During the process of this separation, we separate this glycerin. Then we use the process of bubble washing. Means during the bubble washing, we mix some hot water in the raw biodiesel and we send the bubble. We send the air bubble in that mixture. Then whatever amount of the traces of this sodium methoxide which is present in that raw biodiesel, it will get mixed in the water, and then again we have to remove all this water by using that separating funnel, and then we get the pure biodiesel. Before to use this pure biodiesel engine, again we have to provide the heat because there should not be any traces of water in the biodiesel. So this is the process of this biodiesel production. So we can use this biodiesel in the existing diesel engine. Then we can also store this biodiesel. We can produce this biodiesel at a decentralized mode. Wherever there is an availability of this non-edible vegetable oil, there we can produce this biodiesel. It reduces the carbon dioxide emission. Then we can mix this biodiesel in the diesel. We already discussed it is safe, oxygenated fuel. So this is the biodiesel processor we developed at that time at Parbhani. Its capacity was 15 liter. Here, this is the temperature gauge, temperature sensor. Then this is the tank. Here, sodium methoxide mixture is prepared. Then this engine is provided, and this is the pulley arrangement for the stirring. Then in the inside, the stirrer was provided, and also electrical heater, and all conditions are maintained which is required in the process of biodiesel production, that is trans-esterification process. And after this process, we can remove all this mixture from the bottom. So this is the biodiesel processor, and this is the front view, and this is the side view. This is the complete view of this biodiesel processor. So the process is base catalyzed trans-esterification. Revolution required is 550 to 700. Reaction temperature is given, I already discussed, and its capacity is 15 liter. So this is the inside view. This is the inside view. This is the stirrer, and this is the heating arrangement. And for the reaction, 1 or 1.5 hour is required. And after this process, we get this biodiesel, and this is we collect the glycerin from this by using this separating funnel. So before to use the Karanja and JATROPHA oil, first we use the soybean, then palm oil for the biodiesel production. So this is the biodiesel which is produced by using the soybean, and this is from the Karanj. Again, this is the portable biodiesel processor. We also use the castor oil for the biodiesel production. So the castor is very thick oil. Actually, this castor oil is used as a for the lubrication purpose. We also use this castor. And after this, you see here the color difference. It is very black in color, this castor in its original form. And after the trans-esterification process, we get this orange type color biodiesel. Then here, this is the palm oil, raw palm oil. We use this palm oil for the biodiesel production, and this is the biodiesel. So you may see the color difference. When this raw oil contain some traces of water, and if its free fatty acid content is more than 1, then I already discussed there will be formation of soap. So this type of during this process of this bubble washing, here the soap is formed. We cannot separate this oil from this soap. So there will be formation of soap. Means before to start trans-esterification process, we have to measure its free fatty acid content, and it should be less than 1. And there should not be any traces of water in the vegetable oil. So this is the palm oil biodiesel and we collect this glycerol from this palm oil. We can use this biodiesel for various purposes, for electricity generation in the diesel engine pump set and also in the tractor. We use this biodiesel in all these in the electricity generation, generator, in diesel engine and in tractor. So this is the electrical generator which is available in that college. We use the biodiesel, all the blends 20%, 40%, 60, and also we use 100% biodiesel in that generator. And that generator was successfully run by using this biodiesel. In this biodiesel production process, we already discussed, it requires the oil storage tank. We have to pump that oil. We have to send that oil in the biodiesel reactor. Then it also requires the catalyst preparation tank. And we have to send again that catalyst in the biodiesel. Then during the process of this transesterification, we get the glycerol. It also requires the glycerol settling tank. Then we have to wash that biodiesel in the washing tank, and it requires the water. We get this crude biodiesel. We have to send that biodiesel in the crude biodiesel tank. So these are the different production processes of this biodiesel. The pilot plant can be, now we discuss about this 50 liter capacity biodiesel plant, but we can also install more capacity biodiesel plant. The pilot plant we can also install for biodiesel production. The pilot plant consists of the reaction vessel with heating and agitation devices, then catalyst mixing vessel, settling tanks and washing tank. The JATROPHA oil or any non-edible oil which is blend, we have to blend with the methyl alcohol and catalyst mixture and kept at reaction temperature for specific duration under agitation, and we have to send to the settling tank. The ester is collected and washed to get pure biodiesel, and the capacity of this pilot plant may be 250 liter per day, and the cost of the unit which may be more than 1.5 lakh. So this is the view of this pilot biodiesel plant. So here, this is the trans-esterification vessel number 2. Here we can trans-esterify this non-edible vegetable oil. So one is the mixing tank for chemical. It's a mixing tank for chemical. 2 is the main reactor. 3 and 4 are the settling tank, and 5 it is the washing tank. So it will require some equipments like dehusker, then oil extraction unit, which may be a rotary machine, capacity 40 kg per hour. So its cost, it may be 45,000 for the extraction of the oil, and its capacity is 20 kg per hour seed. Means it can extract the oil from 20 kg per hour seed. Its capacity is 20. Means these rotary machines are available in 2 capacity, means 40 kg per hour and 20 kg per hour, and its cost is given. This is the JATROPHA. This is the mechanical oil expeller. Such type of oil expeller can be used for the extraction of oil from this non-edible vegetable oil. Then this is the filtration unit. The raw oil after this extraction, we have to clean that oil by using this filtration unit. Then for the expeller of the oil, for the different crushing capacities, its capacities are given 250, 400, 600, 900, and its approximate cost is given. So oil expeller are also available in the market. So such type of plant which is developed at TNAU, this is the plant which is developed at TNAU. It was in a very early stage for the biodiesel production. Then this is the net calorific value. Net calorific value. The calorific value of diesel, it is given in kilocalorie per gram. Then these are the different biodiesel. If we prepare biodiesel from rapeseed, then the different groundnut, cotton seed. So it is given, then pongamia, then coconut, castor, neem. So oil carry energy in concentrated form, and its calorific values within 15% that of diesel. Means if we prepare the biodiesel by using all these oils, its calorific value reaches is in the range of 15% as compared to the diesel. 15% less as compared to the diesel. Then crushing capacity per ton, it is given. Cost of machineries, it requires oil expeller, then oil filtration, boiler, conveyor, storage and treatment tank, pipelines, and if its capacity is 1 ton per day on the basis of seed, and then 4 tons per day on the basis of seed, its cost is given. For 1 ton per day, cost will be 4.5 lakh, and here 12.5 lakh. Then biodiesel production unit, here it requires the stirrer, then catalyst vessel, boiler, settling tank, then storage tank. Then the total cost of the plant for 1 ton per day and 4 ton per day, it is given 6 and 16.7. If we compare the properties, fuel properties of this biodiesel, JATROPHA, here JATROPHA occurs oil, then biodiesel and diesel. Here the specific gravity, viscosity, calorific value and flash point. The flash point, the specific gravity of this biodiesel is 0.86 and of the diesel is 0.84. It is the specific gravity of diesel is less. Then viscosity of the diesel is 4.5 and for the biodiesel is 5.2. Means the values are comparable. The calorific value of the diesel is more, 42 megajoule per kg, but here it is 34.5. Means the calorific value of this biodiesel is less as compared to the diesel. And the flash point, we already discussed, the flash point of the biodiesel is more, 175 degrees centigrade, and for the diesel it is 50. So these are the properties, and all these properties, if we consider these properties, we can use this biodiesel in the diesel engine, not in the petrol engine. We can only use this biodiesel in the diesel engine. So again, reduction in exhaust gas emission, it is given. If we use this biodiesel, carbon monoxide, particulate matter, hydrocarbon, sulfur dioxide, and these are the reduction percent, 50%, 30, 90 and 100%. There is no sulfur emission if we use the biodiesel in the engine. And these are the benefits in the biodiesel sector. We can install the separate industry at village level. So this is the agro-based industry, and the business is possible in the area of this agriculture. That is, we can also use the wasteland for the plantation of these non-edible oils. Then we can extract the oil extraction units can be installed. Oil cake distribution, then biodiesel production, biodiesel distribution, glycerol-based chemical. We can use this glycerol, which is the byproduct in the process of this trans-esteparian process. So we can use this glycerol in the cosmetic industries, because this glycerol is being used in the cosmetic industry. Then there are some indirect benefits. We can use this biodiesel in the transport sector. Then seed, oil cake, oil, biodiesel, glycerol, and there will be employment generation if this biodiesel industry is flourish at the decentralized mode. Then to analyze the engine exhaust, like CO, CO2, O2 in percentage of NO, NO2 and SO2 in ppm and flue gases, and it requires multi-gas analyzer. Then diesel smoke tester is also required to test the smoke density. So such type of engine test sticks are available in the market. So these are the different blends of this biodiesel, B20, 40, 60, 80. We can also use this biodiesel in the kerosene stove, but it requires some modification for the lighting of lamps, then running the diesel bike, or in soap making. Then what are the technical and environmental drawbacks of this biodiesel? Up till now, we will discuss all the rosy picture of this biodiesel, but there are some disadvantages also. Despite parameters disadvantages, biodiesel has some technical, economic and environmental drawbacks. Compared to fossil fuel, this biodiesel presents weaker oxidative stability and cold flow properties, and its viscosity is more also its density is more and higher NOx emission. If we use this biodiesel, the emission of this NOx will be more from the vehicle. Then its viscosity as compared to diesel is more, and cold flow properties, because in the cold season we cannot directly use this biodiesel. So we have to mix some chemical to reduce this properties, cold flow properties. The most challenging disadvantage of biodiesel is its higher production cost as compared to the fossil fuel. And the main reason is the availability of the feedstock. Feedstock is not available. Now we are talking about the JATROPHA, but this feedstock is not available in abundance, and inefficient production process. And the production process, we have to check that free fatty acid, the material should be that oil, there should not be any water, means there may be formation of soap. So the chances of the failure of this batch is more, means inefficient production process. Then to reduce the production cost of this vegetable oil, we can use this, there are different materials which can be used for biodiesel production, and in most of the cities now this waste fried oil, it is being used for biodiesel production. Then use of cheaper sources of lipids such as waste cooking oil, non-edible JATROPHA. Then algae is also used. There are some algae which contain the oil, blue green algae. That is one of the alternative source for the biodiesel production. In that blue green algae, the oil is contained, and after extraction of that oil, we can, by using the process of again this transesterification, we can convert that oil into biodiesel. And then recycle grease trap waste reduces cost of production of this biodiesel. So these are the different disadvantages. Again, I already discussed the feedstock results in saponification and emulsification in presence of homogeneous base catalyst, means formation of the soap. Then the alkali catalyst used in its feedstock for biodiesel production at industrial scale are corrosive and difficult to be recovered and reused, and are removed from the reaction mixture by water washing. Means recovery of this methyl alcohol and the catalyst which are being used in the process, it is not easy to recover all this product. It also requires abundant amount of water for the washing of this biodiesel. So these are some of the drawbacks. And ionic liquid is one of the answer. So nowadays, instead of this base catalyzed, this ionic liquid is one of the alternative. These ionic liquids are one of the best alternative to replace alkali catalyst, owing to their unique properties such as non-volatility, excellent solubility for various organic and inorganic material, structure tunability, environment friendliness, and wide liquid temperature. So ionic liquids are organic salt which are composed of cations and anions with melting point of below 100 degrees centigrade. So this is one of the solution where there we can use these ionic liquids. They are nearly non-volatile, soluble in organic and inorganic material, and remarkably less toxic compared to the traditional organic solvent, possess wide liquid temperature and significant thermal and chemical stability, which can be recyclable and environment friendly. So this can be used for biodiesel production. These ionic liquids is a novel catalyst for transesterification of triglycerides into biodiesel and could lead to high yield with the less complex production process, and reduces equipment corrosion, saponification, and waste generation. So this is about the ionic liquid. Then these are some of the photographs. This is the visit of this agriculture commissioner Goel Saab at Umarga district, Usmanabad, in the year 2005. This is old photograph. At that time, Vijay Rao Kulte, he was the vice chairman of MCR at Parbhani during the Ashwamed. We exhibited this model biodiesel processor in the exhibition. Again in 2006, at Parbhani in Parivartan Melava. Honorable Minister of Agriculture, Central Agriculture Minister Sharad Pawar, he was also visited, and I have given some information about this biodiesel production. So same photograph. Then in agrotech at MAU Parbhani, Honorable Minister late Sri Vilasrauji Deshmukh. Nana Saheb Patil, he was at that time Secretary Agriculture. Dr. Sri K.B. Bhoge, he was the Commissioner and ex-Vice Chancellor of Parbhani. Fauzia Khan, at that time he was MLA of Parbhani. So this biodiesel processor is capable of producing biodiesel both from the edible and non-edible oil by using this base catalyzed trans-distribution process. Again, we can use the different processes of biodiesel production. But I use this base catalyzed process, and the fuel properties of this biodiesel, that is the kinematic viscosity, specific gravity, it was found within this BIS standard, and the operational efficiency of this diesel engine pump set that we have been used were found in the range of this 20%, and it is one of the alternative for the non-conventional fuel to run all type of CI engine. So this is one of the recommendation, but we cannot use directly 100% biodiesel in the CI engine. The recommendation is we have to use 20% of this biodiesel. We have to mix 20% biodiesel and 80% this diesel. Then that engine will run satisfactorily, a diesel engine. So there are different feedstock, and all these feedstock are region specific. We can produce this biodiesel at the domestic level if you know the process of this biodiesel production. Anyone can prepare this biodiesel at a domestic level. So I think this is all about. Then these are the different machineries: hand operated JATROPHA decorticator. It is like a or groundnut decortication machine. Then this is the power operated JATROPHA decorticator. Then thermal gasifier to generate gas from the JATROPHA. We can also use the JATROPHA kernels in these thermal gasifiers. We can use this cake in the biogas plant, and we get this organic manure. And we can use this biodiesel in the transport sector. So this is all about this biodiesel. So thank you very much for patiently listening to all the participants.
Thank you, sir. The topic is open for the discussion. I request you can ask the question by raising your hand, or you can put your question in the chat box also.
Good afternoon, sir.
Good afternoon.
Thank you for a very nice and informative presentation on biodiesel production techniques, different techniques. Sir, you have shown, sir, one of the pilot plant which is costing 1.5 lakh, and that the capacity of that plant is 250 liters per day. Here I want to ask that how much raw material is required to run this plant on per day basis?
Actually, from 1 kg of this raw material, we get 25% oil. Means from 1 kg of this JATROPHA seed, we get 250 gram of this oil. And the capacity, how much you mentioned capacity?
250 liters per day.
250?
250 liters per day.
250 liters.
That you have mentioned in the presentation.
So we have to multiply that 250 liter. Multiplication करावं लागेल. मल्टिप्लिकेशन करा देशमुख साहेब. किती होते?
1000 kg. Sir, the another question is why there is no biodiesel pump in our Maharashtra? I have seen the biodiesel pump in Gujarat. There is no biodiesel pump in Maharashtra. And is there any farmer producing company or farmer producing group is involved in this entrepreneurship?
No, actually, biodiesel. I have seen biodiesel pump near to our Akola in MIDC. Now there is one biodiesel pump recently established in our MIDC road, National Highway 6.
One more means it's my submission.
And in Anand Agriculture University, they have established one big plant of biodiesel production. I think you might have seen that plant at Anand. Dr. DC Joshi, now he is the Vice Chancellor at Kota. He has installed that plant, biodiesel production plant, and that plant was inaugurated at the hands of our late Abdul Kalam ji. And there they use this JATROPHA seed for this biodiesel production. And mostly in Gujarat, they use the waste fried oil for the biodiesel production. And you might have seen these vehicles which are running on the National Highway 6 for the road. They use mostly this biodiesel in their engine.
Sir, one more submission is there. Sir, is it possible to open biodiesel pump of our own university and all the vehicles of the university can be run on that biodiesel pump which is owned by university?
Yes. All the forestry scientists they can prepare the biodiesel in their college, and they can supply all this biodiesel to the vehicles. So I can assign that work to the forestry department, forestry college.
If you supply the raw materials, you can produce biodiesel for our university.
Sound is not clear.
So there is very less production of JATROPHA oil from seed. So that is the main hurdle that so many. I am just continuing the Dr. Techno. I think that is the missing link that we are not able to see the.
At present, we cannot use JATROPHA because the yield of the JATROPHA is very less. I already discussed in 1 kg it accommodates 1,350 number of seeds. 1,350 number of seeds. So that seed is very lightweight, and the yield is very less. Therefore, we cannot use the JATROPHA seed. But the alternative is we can use the Karanj. We will
try our level best to supply the raw materials for biodiesel production.
Your sound is not clear, sir.
We will try our level best to supply the raw material for biodiesel production.
Okay. You supply the material. I will produce the biodiesel. Thank you. I know. You have planted the JATROPHA and some other oil yielding plants in your department.
Thank you, sir.
Okay.
Now I request Dr. Rupnath to ask his question.
Sound is not clear, sir.
Sound is not.
I cannot hear.
Sir, you are not audible, Dr. Rupnath.
Hello.
Hello, sir.
Yes. Sir.
Hello.
Yes, sir. Please speak, Bowser, sir.
Yes. Sir, congratulations, sir. You have given detailed information about the biodiesel production. My question is, what is the recovery of biodiesel from the different sources? You have extracted from the different sources. Which crop shows high recovery of biodiesel?
Actually, the recovery of biodiesel, if we take 1 kg of oil, the recovery of biodiesel, we get 90% biodiesel, 90% biodiesel from JATROPHA. Then the recovery of biodiesel from current oil is more as compared to the JATROPHA.
And what will
I have performed that experiments personally in my laboratory, but I have got recovery from the current is more. Means the recovery from the current oil is more as compared to the JATROPHA.
What is cost of production of biodiesel, sir, as compared to diesel?
Actually, sir, it depends on the cost of feed material. On the basis of feed material. If the feed material is available free of cost, if you assume we get the JATROPHA seed free of cost, then the cost of biodiesel will be only 20 rupees 20 per liter if the feed material is free of cost.
And what are you going to use about the glycerin?
Glycerin, we can use this glycerin in the cosmetic industry.
Cosmetic industry.
Cosmetic industry, but we have to purify that glycerin. It also contains some amount of that NaOH or sodium methoxide. So first we have to wash that glycerin, and we can use that glycerin in the cosmetic in the process of cosmetic production.
Byproduct, huh?
Byproduct.
Okay, sir. Thank you.
Okay, thank you, sir. Sir, there is one question in the chat box. Can we suggest biodiesel production plan to farmers in saline tract?
Biodiesel?
Biodiesel production plans for the farmers in the saline tract.
Saline tract?
Yes, sir.
No, we can install this plant anywhere. There is no problem. The land may be saline or fertile. There is no problem. We can use anywhere. Where the material is available, feed material is available, there we can install the plant. Actually, for the installation of plant, what is required? It requires labor, water, then feed material, electricity should be available throughout the day. So these are the requirements. We can erect the plant anywhere.
Thank you, sir. Now, if the voice is clear, Dr. Rupnar can ask the question.
Hello.
Yes, sir.
Hello. Good afternoon, sir. Thank you very much for your informative presentation on biodiesel production technique. I have two questions. My first question is, what is the economic feasibility of a JATROPHA-based biodiesel plant? And is there any adverse effect of JATROPHA on agricultural land? And my second question is, if I want to set a biodiesel plant, then who will be or where to sell the biodiesel? Or who will be the customer of the biodiesel produced biodiesel?
The hours is clear. Swati, please you repeat this question.
Sir is asking what will be the economic efficiency if we use the JATROPHA for the biodiesel?
Economic feasibility?
Yes.
At present, if you use JATROPHA carcass, because this JATROPHA carcass, it is not available, means feedstock is not available in the market. Means the plant which are based on the JATROPHA is not feasible at present. We have to go for some alternate material. It is not feasible. Again, Nantar?
And is there any adverse effect of JATROPHA on agricultural land?
No, there is no adverse effect on the cultivation. Only the problem is its yield. Yield is very less. That's why most of the farmers they uprooted this plant from their field because of the yield problem.
Okay. And if someone wants to set an individual plant for biodiesel production, who will suffer or where to sell it?
Sorry, sir, your voice is not clear. Now I am taking the next question. Sir, there is one question in the chat box from Dr. Vaibhav Ujjal, sir. He is asking, what will be more feasible, biodiesel or battery-operated vehicles? What will be more feasible, biodiesel or battery-operated vehicles?
Battery-operated vehicles.
Thank you, sir.
एक minute. Battery operated vehicle mostly use the petrol. Battery operated vehicle mostly use the petrol, or it may be used diesel, but there is no correlation in between the battery operated vehicle and the use of biodiesel. Actually, biodiesel is recommended to use in the CI engine, compression ignition engine, where the diesel is used as a fuel. So if that vehicle is diesel operated, then you can use the diesel, 20% diesel. You can mix the 20% diesel in that petroleum diesel. There is no problem.
Thank you, sir. Now I request, is there any question from the hall? Participants from hall can ask a question.
थोरात मॅडम काही प्रश्न आहे का? बसा मॅडम बसा.
बायोडिझेल सेपरेट केलं जातं आणि ग्लिसरीन मिळतं. तर ग्लिसरीन तुम्ही कॉस्मेटिक्स म्हणून यूज सांगितलंय, बट हाऊ मच ओरिजिनल ऑइल पर्सेंटेज दॅट यूज फॉर एडिबल पर्पज? इज देयर एनी पर्सेंटेज ऑफ फॉर एडिबल पर्पज?
नाही समजलं नाही. आवाज क्लिअर नाही सर.
जे बायोडिझेल जे आपण फिल्टर करतोय सर, बायोडिझेल तुम्ही युनिट दाखवलाय त्याच्यामध्ये, तर वर बायोडिझेल आणि खाली जे पडतं ग्लिसरीन आपण सेपरेट करतो. यू कॅन सेपरेट दिस बोथ द atoms, that is biodiesel and glycerin, and that is used in cosmetics. But it is possible that glycerin is also for esterification or any other process you can use that glycerin as a human consumption purpose.
नाही.
That's why only waste products you can use non-edible oils.
नाही त्याच्यामध्ये वेस्ट प्रॉडक्ट कोणते आता ऑइल एक्सट्रॅक्शन केल्यानंतर वी गेट द केक. वी कॅन यूज दॅट केक. इट इज अ फीड मटेरियल फॉर फिश. Then we can use that cake in the biogas plant, and after digestion we get the slurry, means we can use that slurry into feed.
आपण जे लिस्ट मध्ये टाकले आहे सर, त्याच्यामध्ये आपण सनफ्लावर्स वगैरे जे पण त्याच्यापासून सुद्धा आपण we can prepare the biodiesel.
Any vegetable oil we can use, any vegetable oil.
पण हे तर कॉस्टली जाईल ना सर, जर आपण त्याच्यापासून मिळतच नाही. ओनली biodiesel we can get and we can get the glycerin. Otherwise that is very costly.
नाही कॉस्टली नाही. आता त्यात जे if we consider the all the by product, means oil cake, then from the seed we get the husk. We can also use that husk for preparing the briquette, or we can use that husk in the process of combustion in gasifier. Then after the trans-esterification we get the glycerol. Actually I discussed this process, batch type of process, but if you consider it as an industry, then that will be more economical. You will get more product, and we can use all this byproduct for its processing. When it means for further processing, then that will be economical.
After all this we can use it. That's why after taking it.
Yeah, thank you, sir. Now I request one of the participants from the hall to propose the vote of thanks on behalf of all the participants joining today, online and offline mode.
Okay. Kalbande sir, on biodiesel production technology. This is a very and to produce step forward towards the green energy production, and we assure you that we will work on that aspect, and yes, we will also think on that aspect to establish the biodiesel plant of our university and run the vehicles. It may be a very ambitious kind of project, and yes, of course, your direction will be a very valuable thing and contribution also. So once again, thank you very much for this very wonderful presentation.
Thank you. Thank you.
Thank you.